I just want to do a real quick video just to go over some extra types of problems that you could see just to make things make a little more sense from the topic as a whole. So here is a question. This was an old AP test question, and I want to bring it up because I usually ask a similar question when I give tests. And here's what it tells us. It tells us that we know f of 1 equals 3. So essentially that's just a point on a function. It tells us that the derivative at 1 is 0. And then it tells us that the second derivative of 1 is -3. And it wanted to know what conclusion can we make about 1, 3. So this was a multiple choice question. And the choices were that 1, 3 is a maximum, 1, 3 is a minimum, 1, 3 is a point of inflection, or 1, 3 cannot be determined. Like there's nothing we can figure out. Or usually the fourth one is just some sort of toss away answer. So let's talk through this. So this tells me that it's just a point on my function. So it's just telling us that 1, 3 is on my function. This piece of information is now telling me that 1 is a critical value because it's a place where the derivative equals 0. And then finally, this piece of information is doing the second derivative test. It's taking that critical value, putting it into the second derivative, and we get a negative value. And our second derivative test says if we have a negative second derivative on my critical value, it's a maximum. So what I can conclude from this is that I know for sure that 1, 3 is a maximum of the graph of f. Next thing I want to do in my little kind of mini topic here is I want to take you through a Delta Math question just to kind of show you some of the things that could be asked of you. They will give you questions that they'll ask you to infer different things about functions based on a graph that's given. So in this particular one, they give you a graph of f. They do tell you where the points of inflection are, which is great because it's so hard to see points of inflection. And then they want to know what can you figure out about the interval from -6 to -4. So -6 to -4 is this little swatch right here. Might want to just kind of like highlight it or kind of make a little mark around that. So let's look at what we know about -6, -4. Well, first of all, -6, -4 is negative because it's underneath the x-axis. It's also increasing because it has a positive slope. And its concavity, it is in this part, which is concave up. It doesn't switch until it gets to -4, so it's concave up. So that's what I know about -6, -4. Based on that, that means my first derivative, since it's increasing, my first derivative would be positive. And let me go a step further. And since it's concave up, that means my first derivative would be increasing because concave up is when the first derivative is increasing. So it's positive and increasing because f is increasing and concave up. On the interval, the second derivative would be positive because it is concave up. And there you have it. I do want to show you one other one that gives a little different piece of information. So some of them give you a derivative graph. Here we go. So this one is a derivative graph. On the derivative graph, we have points of inflection at -3 and 1. And it wants to know what can we figure out about, let me get to it, -1 to 1. So about this little swatch right here. What do we know about -1 to 1? Well, from -1 to 1, the derivative is positive because it's above the x-axis. It is also decreasing because it's on its way down. And it is, let's see, in this little section is concave down. Okay. Based on that observation, the original function, so my original function, since the derivative is positive, my original function would be increasing. And then since the derivative is decreasing, my original function would be concave down. So it would be increasing and concave down, increasing because the derivative is positive, and then concave down because the derivative is decreasing. Because f prime is the graph of f would be increasing and concave down because f prime is positive and decreasing. My second derivative, well, since my second derivative, so my concavity we've said is concave down, then my second derivative, can't talk, is negative because f prime is decreasing. I feel like I might have more stuff to say on that one. I'm going to try to submit it, and if it's not right, I'll go back. Oh, there we go. I guess not. And then it'll go through and explain to you everything else that we know. So those are some of the questions, and believe me, you might have to look at them a little bit because sometimes you kind of talk yourself around and you have to think like, what am I actually looking at, and what are they asking about? Because sometimes you're looking at F, sometimes you're looking at F prime, sometimes you're looking at F double prime, and then you're always being asked questions about the other ones. So it definitely takes a little mental focus to try to keep everything straight in your head.